Hello dear friends, welcome back to the channel Learn with Art. Okay, now in last video we have seen what is mean by left linear grammar and right linear grammar, as well as we have seen what is mean by regular grammar. Okay, now time is to study to construct regular grammar for given finite automata. Means if we have finite automata, then how we can build regular grammar for that finite automata. Okay, so there are, first we have to see some of the rules related to conversion. Okay, so suppose consider that we have given a finite automata, so that finite automata is represented with m, and the tuples for m are q sigma delta q0 f. Okay, where capital Q is nothing but state of all the set of all the states of given FA, that is Q0, Q1, Q2 up to Qn. Then we have considered that is G as a resultant grammar, and G is equal to VTPS. Okay, so these are the tuples to represent grammar. Okay, now we will see how we can correlate the tuples of grammar with tuples of finite automata. Okay, so firstly we will see V is equal to A0, A1, A2 up to AN. Okay, so in case of grammar, V corresponds to the set of states in finite automata. Okay, means what? Set of variables corresponds to set of states in finite automata. Okay, now T corresponds to set of alphabets from finite automata. So set of terminal corresponds to set of alphabets in case of finite automata. Then set of productions, that is P, corresponds to set of transitions, that is nothing but delta in FA. Then start symbol from G means from grammar, that corresponds to initial state of the finite automata. Okay, and lastly we have F, but in case of grammar we don't need to consider the set of final state. So how we have correlated all the tuples of finite automata with the tuples of grammar. Okay, now during conversion method we can directly write the set V, then set T and S also, but we, for conversion of transitions to productions, we have to follow some of the rules. Let's see what are these rules. Okay, so where set of productions P is constructed as, because we have a set of transitions and we have to convert these transitions into set of productions. Okay, so we will see one by one. Okay, so suppose we have a transition of the form delta of Qi comma A is equal to Qj. Okay, if we supply A input to state Qi, then if output state is Qj, and if Qj is not a final state, means output state is not a final state, then for this total transition we could add a production of the form Ai tends to small a aj. Okay, so here Ai corresponds to Qi, small a corresponds to this small a, and aj corresponds to Qj from the transitions. Okay, so means if output state is not final state or it does not belong to set F, then we have to add only one production, that is Ai tends to small a aj. Okay, so same is the case with second rule, that is if we have the transition of the form delta of Qi comma A is equal to Qj, and if this Qj belongs to set F, means this output state is a final state or Qj belongs to F, then we have to add two productions for a single transition, that is Ai tends to small a aj as in the last rule, and we have to add one extra production, that is Ai tends to small a. Okay, so means we have seen that if output state is final state, then we have to add two productions, and if output state is not final state, then we have to add this single production. Okay, and one more rule is there, if Q0 belongs to F, then add a production S tends to empty. Means if initial state itself is a final state, or Q0 belongs to set of final states, means empty is accepted in the language of finite automata, then we have to add a production S tends to empty explicitly. Means what? Start symbol accepts empty string or empty symbol. Okay, so this production we have to add it explicitly. Okay, now we have some of the notes over here. So first is what? The grammar will have n variables if we have n number of states in finite automata. Means if in a given finite automata we have n states, then in the resultant grammar we will have n variables. Q0 is the initial state in FA. If Q0 is initial state in FA, then start symbol corresponds to Q0 in G. Means what? Start symbol from grammar corresponds to initial state of the finite automata. As we have discussed earlier, if there are m transitions in finite automata, then there could be m productions in the resultant grammar. Okay, means how many transitions we will have for given finite automata, that will decide the number of productions in resultant grammar. Okay, so that was related to the rules and the method of construction of regular grammar from a given finite automata.